Okay, so in the book, example 4 is over using a polynomial function and technology to model it. And basically, it goes through the process of taking a set of data like that you see in the table and plotting it on a graph. So there's a way in which on a graphing calculator, like a TI-84 graphing calculator, you can input a list of values and it can plot it on the graph. So that would be like, this would be what you'd see. You'd see a bunch of data points. There is some steps you can go where there's a feature that allows you to do what is a regression. And a regression is a technique. It's a technique you might learn in later math classes, but it's a technique that allows you to come up with a kind of rough equation that fairly well will fit those points. Um, so it's basically the concept is that you can collect data. It might not be the most complete data on whatever you're thinking about, but you can collect some data on some measurable thing out there in the world, and you can use this regression technique to come up with some sort of equation that basically will go through most of those points, or at least an equation that will get very close to as many points as it can. Okay, now you guys don't all have graphing calculators at home, so I'm not going to go through and explain all these details, but if you do have a graphing calculator, you might take a moment looking through the book to look through this example number 4 to see kind of how that all plays out. But as you can see, you end up with a line that passes through most of them, and it'll give you the values of A, B, C, and D in that quadratic equation that it's created. That's kind of that best fit line. Okay, so you can kind of go through on your own if you're interested in that. Otherwise, we're just going to move ahead and look at example number 5 here, which is finding an average rate of change. Okay, so in rockets, the Ares 5 rocket was designed to carry as much as 75 tons of supplies and 4 astronauts to the moon, and possibly even to Mars. The table shows the expected G-force on the rocket over the course of its 200-second launch. Okay, so we can see that at time 0, we start out immediately with 1.34 Gs. The amount of Gs, the amount of force on the body of the astronaut due to how much it's accelerating upwards is going to be diminishing a little bit. However, at about 80 seconds, it turns around and heads upwards once again until it hits a maximum where it comes down afterwards. Okay, so sketching the graph, we end up with a graph like that on the right, and we can estimate an average rate of change of acceleration. Okay, so from the graph, the change in the y values is about 0.9. So we're saying from the very beginning to the very end, from 1.34 to 2.2 on the table, at the beginning and the end of our table, we go up about 0.9. Okay, so we go up about 0.9 and it takes us 200 seconds. So there's 0.9 Gs over 200 seconds. And if we use a calculator or do that through long division, either way, we would get 0.0045 Gs per second. That would be our rate, our average rate of change, 0.0045 Gs per second. Okay, so like whatever that is, 0.4% of a G per second. That a G is the amount of force due to gravity. Okay, so the amount of G's is increasing that much per second. Okay, finding it algebraically, they're describing that you're doing the function at the end minus the function at the beginning. So that's that 2.2 minus 1.34, the outputs of the function at the end and the beginning, which is this point and this point. So they're saying the difference there. So they want this one minus this one. So we figure out how different are these 2 points, what's the distance in between them. And we're going to divide that by the values on the bottom from 0 to 200. So in effect, we are doing rise over run. We are finding a slope of a line that passes through those points, which is our definition of the average rate of change. Okay, doing that algebraically, basically get the same number. let me erase that. From 0 to 200 seconds, the average rate of change in acceleration was an increase of, okay, just what we were writing, that 0.0043 Gs per second. Okay, and that is all for this lesson.